For designing a new device, I would like to know the ignition delay of a hydrogen mixture at specific conditions. Experiments often take too long and a lot of money to set up and perform with accuracy and precision. For some experiments, it may be difficult or even impossible to measure things you need to know. Wouldn't it be easier to predict the results based on the current knowledge we already have? Then easily make changes to the experimental setup, and recalculate the new predicted values. With the PrIMe infrastructure, you can. To answer my question in the PrIMe environment, I start with creating a workflow, by dragging and connecting components. This workflow has 3 components. This component defines the initial state. This component loads the archive data. And this one runs the prediction. Running the workflow is simple. The initial state component opens up a form, allowing me to set the conditions and mixture composition for the initial state component. Then, with the data set component, I search for data and experimental results archived for the system in question. I will search for the hydrogen data set. This data set contains data and models of 12 different experiments, related to the ignition delay we are looking to predict. The third component executes next, opening up our prediction tool. I run the prediction and view the results. The answer is shown here. The ignition delay is predicted to be between 20 and 30 microseconds. Note this answer is not a single number, but a range. The length of the predicted range reflects all the uncertainty of the data and model used to make the prediction. I also get more information that shows how the experimental and model uncertainty affected the prediction range. This information can be used to make more refined predictions, by allowing me to determine which experimental data may be causing wider prediction intervals. By joining PrIMe, you can actively participate in further development of the PrIMe community and infrastructure. Thank you for watching.